Welcome to the Databricks Skill Builder series. We're glad you're here.
Okay. Good morning, good afternoon, wherever you all are. My name is Justin. I'm the PM for Photon. And with me, my trusty sidekick, the one and only Alan Choi. He's a member of the field, specifically, like there's a specialist organization that deals with just crazy customer problems and performance stuff. And that's Alan. He's one of the Jedi of that team. So super glad to have him. And so I'll do part of the presentation, and Alan will jump into it as well. As Stephanie said, just to reiterate, if you have questions, feel free to put them in the Q&A if they're shorter questions. Alan will be answering those while I talk. And then, and Alan, also feel free, pause me in between slides if there are questions, as I'm not going to be monitoring the questions as we go. And also, if there's longer questions, feel free, raise your hand. And again, we can moderate those and ask along the way. We're planning probably there's 20-25 minutes of content. So please bring your questions. Would love to tell you all the things about Photon. So with that said, let's get started. Oh, wait a second. Okay, so what do customers want? Basically, customers would like to reduce complexity, infrastructure costs, and enable faster iteration for these engineering teams. And after talking to hundreds of customers over the years, like these are themes that keep showing up. And a way to do that, at least our point of view on doing that, is if you can standardize on a single set of APIs, that you can do exploration on big data, small data, low latency queries, batch, streaming, and even featureization for ML workloads. Standardizing on one set of APIs helps reduce this complexity, helps reduce infrastructure costs, and enables this faster iteration. What you don't want to do is do your development work in one language and then productionize it in another. You're just wasting time and cycles. And so if you have a simple API, it's only going to remain simple if you have also a simple architecture for your underlying data. And that's what Databricks calls the Lakehouse. The idea is have your data in one single place and then be able to do all of the workloads on top of that. And in order to do all the workloads, that's where you have a fast engine. And that's what we're talking about with Photon. And so I'm not here to pitch the Lakehouse. Hopefully you've heard of it, but the idea is simple. So simple in terms of architecture, open in terms of built on open source and open standards, and multi-cloud. So being able to select star from a table, and it can retrieve itself from Azure or GCP or AWS, and the underlying analyst doesn't need to know. And so within the Lakehouse, there's the data reliability and performance, and that's where we play, and specifically in the realm of query processing. And so with query processing, the idea and the ethos of the team is that you can get the same or better performance as a proprietary warehouse via open formats, cheap, elastic compute, and storage. And so at Databricks, and we'll kind of narrow this down. We keep double clicking. What is query processing? And query processing are many engineering teams. And so this just gives you an idea, just a quick glance. I'm not going to talk about all of these things. If you'd like to talk about all of them, of course we can. But basically, when you submit a query, you have queue admission. And in that, in Databricks, we have a dual queue that looks for short versus long queries to try to make sure that we get, basically if there's a long query running, if it takes an extra second, no one's going to know. But if you submit a short query and it takes 30 seconds, people know and feel it. There's planning, scheduling, there's result caching, processing. So that's specifically Photon engine, and that's what we're going to spend a lot of time on today. And then if we keep going throughout the stack, we have storage with Delta Lake, and then the catalog, which is Unity catalog, which I believe GA is today. So perfect timing. But either way, we're going to spend some time now talking about Photon. So I know I took a few minutes to kind of introduce, where Photon fits in the stack. If there are any questions, Alan, feel free to holler them out. I'm going to keep moving. All right. What is Photon? Glad you asked. So Photon is the next generation engine for the Lakehouse. And in the top right, you can see it's generally available. This is huge. Within the past week or so, Photon is now GA in the workspace. And for those of you that have been using DB SQL, it has been generally available ever since DB SQL came out. So Photon is the underlying engine that's doing your SQL queries in DB SQL. If you're in the workspace, you're using notebooks, then Photon is the engine that you can use in order to do your ETL or exploratory data analysis and even productionize some of your jobs. But Photon is cheaper and faster, so it's built from the ground up for the fastest performance at lower costs. And during the preview periods, Photon provides up to 80% TCO savings while accelerating data and analytics workloads up to 12x faster. And the way I like to think about it is, if we're talking about ETL, it's all about cheap. Photon's going to be much cheaper for your runs. If it's for analytics workloads like user, interactive workloads, exploratory data analysis, then Photon is just faster. Built for all the use cases, as I was talking about before, it allows you to standardize on that one set of APIs to do all of the things that you want to do. And the best part is no code changes. I'm working on a blog right now with a major manufacturer, and they loved it. They just clicked the button, use Photon, and they were able to get the up to 80% TCO savings and then an enormous speed up. It's an ANSI SQL compliant engine, and it's designed to be compatible with the modern Apache Spark APIs, and it just works with your code. Again, there's nothing you need to do to take advantage of it besides launch a cluster with that's Photon enabled. And what are customers saying? Throughout the preview process, there's kind of a lot of different themes, but an insurance company, he had a 5-minute query running on Redshift that took 35 seconds on Photon. A retailer leveraged DLT and they reduced their overall latency by 5x, and their overall cost, it was 20% of the previous cost to run it, so cheaper and faster. A manufacturer had a 13x speed up. A media service, just by turning Photon on blanketly to all of their jobs overnight, saved more than 30% on their total EC2 bill from one day to the next. So that was pretty cool. A fintech had a 5x performance, and an automaker saw a 3x performance. So a lot of different things here that are happening, but overall cheaper, faster. That's the value that Photon is bringing. So I'm going to spend the next few slides kind of going through, and actually I'll just take a pause, take a look at the Q&A real quick. Prior to Photon, Spark did this. So I assume you're probably talking about the different APIs or being able to do those workloads. Yes. So basically, prior to Photon, Spark did it. But if you want to get into low latency, if you want to get to fast, all those things, Spark wasn't doing that as great. Spark, I mean, if we go back to its origins, was originally made for huge batch jobs. Photon, the underlying architecture, and also what we did is we wrote it in C++. So we're trying to get as fast or as close to the metal as possible to deliver the most speed. So to me, it's just like that's it's a kind of different design. And yes, Spark did some of the things, but Spark didn't do all the things. So I'll let Alan keep typing away. Thank you, Alan. And we'll get back to the slides. So ETL and Photon. Let's talk about DLT, an example of DLT at a large warehouse retailer, and we'll kind of double click on that. The business wanted faster access to data sets for inventory and accounting reports, and the architecture was pretty simple. So it's a Delta Lake merge between a bronze and silver table. And just by leveraging Photon, it ended up being a 55% TCO reduction and a 5x latency improvement. So I have a sample architecture, bronze, using Photon to silver, doing some reports off of it, and we can see the visual. So using Databricks runtime, it was 15.5 minutes. Leveraging Photon, it went down to 3.5 minutes. So super fast and ultimately a lot cheaper. So DLT is also GA in the past few months. So if you haven't heard of DLT or Delta Live Tables, feel free to reach out your account team or check out the product page for it. Super awesome technology. Gives you data quality and variant checking. You don't have to worry about how much compute or all those things. It just works. It's really fast.
And one of our sessions this month, towards the end of the month, is Delta Live Tables. So feel free to catch that as well.
Perfect. Love the plug. All right, CDC and Photon. So another sample use case. So a Delta Lake merge. Basically, this was a fraud detection use case, trying to find at a fintech. So basically, finding other recent loan applications. And we leverage things like low shuffle merge. That's a recent Delta Lake feature. Basically, this allows your merges to happen a lot faster. And when you use Photon for this, it makes it like a 5x speed up in the merge. So if you're using Delta Lake merge, just use Photon. The being vectorized, it just makes things happen a lot faster. And also within Delta Lake, we are leveraging the CDC feed. And so this allows you to emit the changes to other downstream consumers, for example. And the overall result was a 66% TCO reduction and a 4.2x latency improvement. So we started out with Oracle, we went into Kafka, and then from Kafka to Photon, and from there, Delta Lake, the CDC feed, and analysts are able to read directly off this feed to understand what data is changing. And then they also have we're also porting this data into Elasticsearch, and the web app is actually feeding off of Elasticsearch, and they're using that basically to look at are people applying for a lot of loans throughout many different places, and if they are, that's a potential fraud. So you maybe don't want to fund that loan. So what used to be like a 24-hour SLA is now about a 3-minute SLA at the very most. So I think this saved millions of dollars. And we have going from nearly 10 minutes down to 2 minutes and a total cost reduction that was pretty enormous as well. Streaming ingestion. This is another common thing. This is super cool. So starting with your raw data. So this was at a media company. Marketing, we're trying to bring in clickstream data from other partners. And so just taking a daily dump of data, which is about 700 gigabytes of CSV files. I think it was like 21,000 files, doing a very lightweight transformation and writing that into a Delta table. And so recently within Photon, we have a feature called all data sources, and that's what enables this process. But just by using Photon for this versus Databricks runtime, it was a 19% TCO reduction and a 2.7x latency improvement. So just using CSV to Photon, writing out to a bronze table. And overall, going from 7 minutes, 18 seconds down to 2 minutes, 42 seconds, and reducing the total cost, 19.28 down to 15.6. So again, just by selecting a single field in your cluster definition, people are saving money and things are happening faster. It's pretty cool. Now, the last thing I'll leave you, and then Alan is going to jump in and do a few slides. This to me is super cool. I'm super passionate about it. Developers are iterating faster using Photon. So for example, in the workspace, people are doing exploratory data analysis. And before we went generally available, we actually sent a survey out to 400 different customers using this. And 90% of them reported faster query execution in the workspace, and 87% can get more work done due to this faster execution. So really it's time equals money. Faster iteration for teams means a lot. So really it's all about developers are able to get more work done faster. Now with that said, I'm going to hand it over to Alan, and Alan, I'll drive the slides. Just tell me when you want me to click.
All right, hey, sounds good. Thanks, Justin. All right, so does my old video show up? No? Okay.
Yes.
Anyway.
Yep.
It does. Okay, great. So what we want to talk about is actually total cost of ownership. What we want to really talk about is that when we think about total cost of ownership, it combines with two things primarily. One is that, hey, how much you pay us in terms of dollar DBU? It's like, oh, if you use a five node cluster, you pay X. If you use a 10 node cluster, you pay 2X. That's a DBU. But more importantly, there's a hidden charge here, which you might not see, is the VM underneath the cover. If you run a job here, you need hardware to power you. So a typical TCO would look like this. You pay $4 to run your whole job, like from end to end. It may take, let's say, 1 hour to run it. Now, that $1, if you break it down, you may pay $3 to run the VM and $1 to pay Databricks for the software on top of it. Now, what we want to tell you, the message is that TCO goes down with Photon. But how does it go down? If you look at the base price and say, hey, Photon with a multiplier, like you are going to cost each unit is going to cost higher in terms of DPU. So you might be surprised, okay, higher the price, how come it's going to save you money? The magic is that you're going to have a much shorter running time. Your 1 hour job no longer runs for 1 hour, but it's right now run for 30 minutes. What it means to you is that instead of paying $3 for the VM, you pay $1.5 for the VM. You save $1.5 there. Now, for the DBU, it used to cost you $1 to run for 1 hour. But the multiplier effect in the Photon means that, hey, if you run it for the whole hour, you are going to cost you roughly around $3 to pay for Databricks. But you don't run 1 hour anymore. Right now you're running for 30 seconds, so for 30 minutes. So what you're going to pay for is at $3 per hour. Half an hour, you pay roughly like $1.5. So you can see that the total cost is like $3 to run it, even though the sticker price, the per unit sticker price of Photon is higher. Now, the more interesting thing is that you might say, oh, it is so 3 times fast, so it's 3 times more expensive. So does it mean that my job has to run 3 times faster in order to save me money or break even? No. What you can see is that, yes, the sticker price is 3 times higher, but even though we're only 2 times faster, you're already saving 26%. So you don't even need to be 2 times as fast in order to break even when you use Photon. But most important, what you say is that we expect you to be 3 times faster. So what we want to say is that we do expect everyone to save money when you move to Photon. And in this example, this is what you can say. Your $4, go back to $3, you save 26% TCO saving, primarily because you're saving on the VMs. All right, okay, next slide.
Yeah, and I'll just add, like, the way I like to think about it is when you submit a job, doesn't matter whatever the engine is, you're asking it to do a finite amount of work. And the difference is Photon can just do that work faster. Therefore, you need less compute in order to make that happen.
So, okay, since it's all good, so how do I enable it? When there are 2 ways you do it. If you go to your UI, there's a very simple button that you just click on it, use Photon acceleration. I'll say use 11.1, that is our GA version. Just click on use Photon acceleration, boom, you're good to go. Very simple. Now, on the other hand, you say, hey, some of my cluster, I used Terraform, like my infrastructure as code. You can do that code too. So here's a script that on the left-hand side that shows you how you can use the Photon. So you can see that there's a Photon equals true on the left-hand side is on bold already. So that's how you can turn Photon on relatively easily. Very minor change to your existing Terraform code and very easily do it on the UI. All right, next slide. Okay, roadmap. A lot of exciting things has happened before. Like in the past, we started the GCP preview. We added a lot more AWS instances. To more recently, we add a sorted window in the preview right now, and we also saw that, hey, structured streaming is one of the very popular ones. So we also started a private preview. Now, with structured streaming, we see, hey, different format is streaming in. Sometimes you do CSV, sometimes you do Airflow. So those, we have a native Photon reader to process this very, very efficiently. So you can see that in the past half a year, we have a lot of things going into the, the most interesting I want to point out is the Photon instance. That's really huge. So it gives us a lot of price performance boost when using the Photon instance. But what I can say is that in the past, we've done a lot that gives you the performance boost that we have right now. But in the future, we're still going to do a lot more. Can you go to the next slide? So what is going to drive the roadmap is the three key things. We want to be best in class in analytics. We want to make the ingestion easier and faster. And finally, we still want to focus on the performance side. Now, what does it mean by the analytics? Low latency BI is a key thing here. We want to continue to improve the BI workload. If you look at, okay, so what does BI workload do? Most of the time people ask is that, very simple question. Hey, give me the top 10 stores that has the best sales. This is what I call the top 10 queries. If you write it, it would be like order by limit. Or give you the, hey, the best salesperson within this region, the top 5 salesperson in this region. There's also order by your sales number by a limit. This is what we call the top K queries. We're going to make this optimization in Photon. The second one is a window function, is a very popular one. If you want to do more advanced analytics, window function necessary. And we have window function private in here already, and we're going to continue to add more and more support for window function. And most importantly, if you want to do more analytics, sometimes you need UDF support. So Python and Panda UDF support is coming on down the road. So that's for the analytics. So next is the ingestion. You need to get the data in faster, and more quicker. So we're going to get support from like Kafka, Kinesis, all this kind of stuff. And JSON is a very popular one when we look at it. JSON is one of the very popular format being ingested. But we want to convert this more efficient in the data such as the query more efficient. So the native JSON scanner is going to come here soon. And price performance, the last one, is like two key things. Most of the data is going to be in the Delta Parquet format. And we have a new vectorized Parquet scanner to make the scanner more efficient. There are a lot more things going on in here. As a database person, I can more dive into it. But the key result for you is that you don't need to change your data. It is just going to be faster. And the final is shuffle performance. Like we have to shuffle a lot of data when we do like join or hash or even do, let's say, hey, optimize C order. Sometimes you have to shuffle the data around. And this is, so we're going to make more improvement over there. All right, next slide.
Whoops, there we go.
Oops. Okay, so what is the key takeaways here? It's faster, it's cheaper. That's the key things that why we're building it. And you have seen it, hey, our customer have told us that the saving is actually real. It's not just we're talking about it, they experience the saving. So Photon is built for all use cases, like BI, streaming, ingestion, ETL. We build it to replace Spark. That's what we want to do all the use cases. And it's also transparent to you. You don't need to do anything. Click on the button, change the way that you start a cluster, your code will continue to use it. But one thing I want to say at the beginning, or someone asked a question, say, hey, so what are things that doesn't work well? So we're not targeting machine learning use case for right now. But other than that, there's a whole bunch of use cases that Photon is really good for. So yeah, just check the box and accelerate your workload.
Great. Yeah, and
let's see if we have any.
Yeah, and the other thing I'll also add is, because I've heard like with as far as ML use cases, I've heard from a lot of customers, I've heard from a lot of people in the field, like when will you have a DBR ML or an ML runtime with Photon? And as Alan was saying, it's just not something we're focusing on right now. For ML can mean so many different things. There's a million different things it could mean. And so how we like to think about it is, to me, there's a few core things. For example, Python UDF support, Pandas UDF support. So since we don't have those, that's mainly one of the reasons why we're, not really considering ML just yet. But I would look for something. I mean, 6 months from now, we'll probably be singing a different tune. The other kind of anecdote I'll add is this is the fastest growing product in Databricks history. So there's a ton of customer usage. Like if we look at even a quarter ago to now, there's up and to the right, and then there's way, way up and to the right, and we're more of way, way up and to the right. So significant usage and significant adoption. And the last thing I'll say is reiterate, we're generally available in the workspace within the past week or two. So pretty exciting time. And that's what I'll leave you with. So again, it's been an absolute pleasure, and Alan and I will stay on and keep answering questions.
Great, guys. Thanks so much for coming. Appreciate being able to answer questions. You did a great job. I'm really excited about all the new stuff coming, and about just the success that I've seen so much with my customers so far. A lot of customers who are excited. I've got one who's just through the moon or for the moon, something like that. For Photon, it's been really impressed, and so excited. Glad we could
Cool.
share this. Any other questions from anybody before we go?
Yeah,
Feel free to raise your
I guess
hand.
I'll just add, like, there's a really good session at Spark Summit, kind of talking about, you'll see some of these slides are very similar, but you'll also see the inner workings. So if you want to learn about, a vectorized engine, like how do we think about it, or how does Photon really work, like the internal aspect, just go to the Data and AI Summit page, search for Photon, and it's right there.
Great. Awesome. Well, thanks so much. And oh, we have a hand. Here we go. All right. If you want to go ahead, you should be able to unmute yourself now.
Hey, Manoj, I think you're going to want to unmute yourself. I can ask to unmute. All right.
All right. Well, then it looks like we've got everything taken care of.
And Manoj, are you going to ask something? Feel free. No? Okay.
Oh, it looks like you're finally off your mute. You want to go ahead and try?
Okay, the question here is, eventually, Photon will implement all the APIs that Spark provides right now?
So let's see. So basically, I always say, like, modern Spark workloads, like we have to prioritize all the things versus the ones that are commonly used. So the one caveat, so Photon works really well, Spark SQL. It works really well, data frame, whether you're in PySpark or using Scala, using data frame API there. The one thing we're not going to implement is RDD support. And when we look at the total fleet usage of RDD, it's pretty low. So that's really why we're not doing it. It's not worth it. And also, RDD is too tightly coupled to Java language itself. And since Photon is written in C++, like, there's just not really a good path in order to make that happen. So that's where it's just like data frame, Spark SQL. And then as soon as you're in like Spark SQL, for example, or data frame, there are 350 and constantly rising expressions. And we are in process of knocking those out. So that's where it's just like, yes, things are being constantly added. We're very much though at the long tail of the engineering effort. In fact,
but right now, as an user, I don't have to worry. I will use the same API call behind the scene. You will invoke which engine suits for that load.
Yeah, absolutely. Yeah, and that's exactly, I'm going to get you that link to the Data and AI Summit talk, because
Please.
Yeah, because it really kind of goes through like how to a mixed plan, part Spark or part DBR, part Photon. Like, what does that look like? Here.
Yeah, I will appreciate it. My
Yeah,
background
no
is,
problem.
I worked a lot with Hadoop in the early days and Spark.
Yeah.
Then I left, and now I am coming back again into the data analytics.
Welcome back.
Field.
Yeah, so I just put it out there. Can you see it? Oh wait, no, I'm going to put it out to everyone. Sorry, that's why you can't see it. There you go. Yeah, this is a really good talk by the engineering manager, Shriram. He and I were supposed to do it together, but my wife had a baby like 2 days before Data and I Summit. So otherwise you'd hear my voice on it too. But yeah, there's nothing you have to do from a user besides just run a cluster using Photon, but there's no specific like photon.call. There's no API that you have to invoke. It happens automatically behind the scene. And really a kind of a way to think about it is Photon does a search and replace on the query plan. So we look at the plan, we interrogate it, and we say, okay, you're asking for a sum function. Super, super simple. We're going to do an aggregation. We're going to do a sum. So Photon says, hey, I can do an aggregation. And oh, I also have the sum expression. So I'm going to swap out the JVM expression for a C++ expression.
Okay.
So think about it as just these kind of microkernels that get swapped out. So Photon looks at the plan. It swaps out different pieces of the plan. Photon has a bunch of different, like we do joins differently than Spark in a good way. And so we kind of just remove things around the plan, re-architect the plan, swap out expressions for C++ equivalents, and then we run the query.
Okay.
Yeah.
So we can assume eventually ML will also move into Photon.
I mean, it depends on what part of ML. I mean, there's the famous Google thing. It's like 15% of the actual code is only spent on ML. But it really depends on what you're trying to do. Are you in the early like featureization phase? Then if so, yeah, you'll be able to use Photon for that. Are you trying to do like Horovod runner? Like, is that running pure in Python? Are you doing like single node? I mean, there's just certain things that don't make sense to use Photon, but we see the vast majority of ML things will be able to be done in Photon, but there are going to be certain things where it just doesn't make sense.
Okay.
It's like it's just like there are certain things right now in ML where you're not using Spark. You're just using native Python. So it's the same correlation.
Okay.
So I don't know if this question was answered. I was kind of.
So underlying architecture in Photon also MapReduce or something different? So if I have a problem that doesn't fit well with MapReduce, can I use Photon, or this goes very much, MapReduce?
So I mean, think of the same for the same reasons you'd use Spark, but you want it faster, you'd use Photon. So for jobs that need that shape that you'd use Spark for, or for analytical queries in general, like, ETL.
So that means you are going to divide into map process, and that gets executed in different machines on different chunks of data, and then your reduce function is combining them. Is that the execution plan for Photon also?
It depends, like if you have a short query that doesn't need to be distributed, we're not going to force it to be just for doing it. So it depends. But the way to don't think about map, don't think about reduce. Just think of what are people typically doing for exploratory data analysis? What are people using for ETL? These type of things are in the wheelhouse of what Photon does well. Like I just like thinking about the high level use case, not like the underlying how's it working.
Yeah, my background is basically developing distributed systems, so I'm curious, how the architecture is.
Yeah, take a look at that. I mean, because I think start with that link to the data and AI summit slides, and you know, from there you'll be able to see.
Okay, thank you.
Yeah, no problem at all. And then let's see. And then David, I am looking at your question right now. Where can we get a list of all preview features and how to enable them on internal workspace for testing? So I'm putting a link. That link is for, hey, here are the generally available features. Now, as far as the internal preview features for testing, we don't have a list of those right now, but I can tell you verbally, like if you're looking to test, like if you're looking to ingest from, say, Kafka or JSON, we'll have a preview testing available for that within the next few weeks. So if you have a use case where you're doing streaming ingestion effectively, then go ahead. You can, I'll put my email address right here, justin.brees@databricks.com. So yeah, if you're interested in doing streaming ingestion with JSON, Kafka, Kinesis, Event Hub, any message queues like that, feel free, just send me an email and I can get you on the preview for that. That will be for 11.2, so coming out in a few weeks.
Anybody else? Any last takers? All right, then I'll let you guys have the last 20 minutes back. And thanks so much for coming and sharing your experience with us. And thanks all our guests.
Yeah, thank you, guests. Thanks for your interest in Photon.
Thank you very much.
See ya.